Hello and welcome to our lesson on 6.6, solving systems of linear inequalities. We'll start with the definitions. Linear inequality, you've already seen this, but we'll go over it again. It's like a linear equation where the equality symbol is replaced with an inequality like less than or equal, greater than or equal. Solutions of a linear inequality, that's going to be any ordered pair that makes the inequality true, and there will be more than one of those. Systems of linear inequalities. Now a system is going to be a set of two or more linear inequalities containing two or more variables. We'll just deal with two variables and most likely two, maybe three linear inequalities aside from what we call the common sense ones, where in a story problem that you have to have positive values. And we'll cover that when we do the word problem. Solutions of a system of linear inequalities, similar to solutions of just a linear inequality, they're all the ordered pairs that satisfy both inequalities of the system. So it's got to satisfy both of them. And so let's go back over how to do graphing here. We have y is greater than 1 and 3x plus 6y is less than or equal to 12. We're going to graph it on this first graph here and just identify two solutions. Before I get started, I'm going to convert this 3x plus 6y less than or equal to 12 into slope-intercept form, because just in case in the future this coefficient of y, if it's negative, or if there's some work you have to do that causes a negative to be divided or multiplied, the inequality changes direction. So we're going to make sure that we're in good shape on that. Subtract 3x from both sides, similar to how we did the benchmark, the first benchmark. And 6 over 6 is 1, so we get y less than or equal, you don't have to flip the direction. 12 divided by 6 is 2, minus 3 over 6 reduces to a half x. So we're going to use this for our second inequality there. Alright, so this inequality will be what is graphed here. And here we go. We have y is greater than 1. Greater than means it's going to be a dashed line. We're going to shade above. We'll go with the blue pen here. And then the green, that's this inequality over here. We're going to do y-intercept of 2, slope of down 1, right 2, down 1, right 2. It's a solid line because it's or equals. And we'll use the green to shade, in this case, below all this space here, which causes us to really find our solution right in here. So I'll just erase the majority of this. Alright, so now we wanted to list the two solutions, and there's many that we could choose. We'll pick lattice point, fairly simple ones here. Alright, so it looks like I'm going to say negative 2, positive 2, and negative 3, positive 2. And there are an infinite amount of answers, but negative 2, 2, and negative 3, 2 are obvious to me. We'll graph the second system here. I'm going to ask you to try it on your own and then have a look at it. Okay, when we graph y greater than 4x minus 1, we graph it like a line. We do y greater than is the blue here. It goes through the y-intercept of negative 1. The y is greater than or equal to 4x plus 1. Same slope, different y-intercept, and this one shades above for the green. And we shaded above for the blue. So the blue shades above. The green shades above. And we have quite a bit of region that is a solution, not including in between here. In between here only works for the blue inequality. So we can pick any point on the green line or above, and it works for both inequalities. Whenever possible, I try to choose points that are on axes. They're just easier to work with. In this case, I'm going to go with the point 0, 2, and let's go with negative 1, 0. It's probably worth checking these answers. Let's just try, and you can go back and check the other ones as well. If I plugged in 0, 2, I'd get 0, and 2 is greater than negative 1. If I go over to the green one here, I plug in a 0 and a 2. 2 is greater than or equal to positive 1. So they certainly work. Why don't you try this one on your own, and we'll see you in class.